pupils, parents, and guardians. Let me start by thanking you for being a part of all our remote learning platforms, particularly our television program, The Classroom in Your Home. Each feedback has been awesome. Good job, you. Our teachers have been working assiduously to bridge the learning loss during this critical period. Therefore, I am pleased to inform you that the Classroom in Your Home has been extended to accommodate the lower primary classes and a dedicated lesson to cater for our special needs pupils in line with our mandate of providing an all-inclusive and quality basic education in our dear state.
Hello pupils, you're welcome to another wonderful edition of your favorite program, The Classroom in Your Home, a program organized by the Lagos State Government and packaged by the Lagos State Universal Basic Education Board, Lasubeb. It is to ensure that you are academically engaged in addition to what you are learning in school. I call that blended learning. I am Auntie Fumi, your English Studies teacher, and I have with me, as usual, your wonderful teachers.
Hello children, I am your mathematics teacher, Uncle Agbaje, but you know me as the mathematician.
Uncle Popo is here, your general studies teacher.
And we also have a wonderful sign language interpreter in the house, Uncle Wale. Together, we are bringing the classroom into your home. Please stay tuned. You're welcome to Auntie Fumi's class. In our English Studies lesson today, our focus will be question tags. Yes, question tags. Before we go into the learning objective for today's lesson, let's have the correction to our homework. I'm sure you all did your homework. Well done. You were asked to use the following words in sentences. In our last lesson, we formed nouns from adjectives. So, we have successful, success, painful, pain, joyful, and joy. They are nouns and adjectives. So these are the sentences I have. I know you have different sentences, but this is what I have. You have something close to that? I trust you and I celebrate you with a cheer. Good job, you. Now to the learning objective for today's lesson. Don't forget I said we're looking at question tags today. By the end of today's lesson, you should be able to appreciate the idea of question tags. Not only that, you should also be able to change statements to questions and use question tags. Let's begin. What are question tags? Question tags are phrases in question form, which are asked at the end of statements. You make a statement and you ask a question. So, question tags are phrases in question forms, and they are asked at the end of statements. We also call them question phrases. We call them what? We also call them question phrases. We normally use auxiliary verbs in question tags. You will see that as we move on. Now, what are the rules to be observed in forming question tags? If you want to form question tags, what are those rules that you must observe in forming question tags? The first rule: if the statement is affirmative, that is positive, the question tag is negative. Note that, please. If the statement is affirmative or if the statement is positive, your question tag must be what? Negative. Good job, you. Note that. That is number one rule. If the statement is positive, your question tag will be negative. If your statement is negative, your question tag will be positive. Well done. That is rule number 2. It says, if the statement is negative, the question tag is affirmative or positive. You already have that. The next rule, the tense of the verb in the statement should be used in the question tag. When you have a tense in the statement, you must also use the same tense in the question tag. That is another rule. Then, pronouns are used in question tags instead of noun. Remember what pronouns are? Definitely. I trust you. Pronouns are used in question tags instead of noun. Now, let's look at example of affirmative statement or positive statement with negative question tags. Rule number 1 says that when your statement is in the positive, your question tags will be in the negative. So let's look at examples of affirmative statements with negative question tags. Are we together? Well done. An affirmative statement is the one without the word not. When we say a statement is affirmative or positive, you will not have any not there. So, an affirmative statement is the one without the word N-O-T, not. Look at examples now. She is going to work. The statement is, she is going to work. That is a positive statement because you don't have the word not there. She is going to work. The question tag is, isn't she? Isn't she? You have a positive statement and the question tag is in the negative form. Well done. He goes to work. He goes to work. Doesn't he? He goes to work. Doesn't he? Don't forget, rule number 1 says if the statement is in the affirmative, the question tag will be in the negative. And it said the tense used in the statement must also be followed when using the question tag. So that's why you have goes and doesn't, is, isn't. Are we together? Well done. Number 3 example. She went to work. She went to work. Didn't she? Went, past. Didn't, past. Did you get that? Well done. She went to work. Didn't she? He has gone to work. He has gone to work. The question tag will be what? Hasn't he? And your question mark. Example 5. She will go to work. She will go to work. That is the statement. And the question tag will be what? Won't she? Are you enjoying the lesson? Very simple. Now, other affirmative auxiliary verbs turned into negative. We're looking at other affirmative or positive auxiliary verbs turned into negative. Shall. Shall. It's turned to shan't. Shan't means shall not. The short form of shall not is shan't. Another one, can. C-A-N. Can. It becomes can't. Can't. That is the short form of cannot. Can't. Must. M-U-S-T. Must. Becomes what? I can hear you loud and clear. It becomes mustn't. 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 Could. Could becomes couldn't. couldn't. Might becomes mightn't. That is the short form of might not. Mightn't. Ought. O-U-G-H-T. Ought. I ought to go there. Ought. We give you the negative form will be oughtn't. Ought not. Oughtn't. Should. Should. Shouldn't. Shouldn't. Are. A-R-E. Are. We give you what? Well done. We give you aren't. Aren't. Are not. Aren't. Where. W-E-R-E. Where. The negative form will be weren't. Weren't. Now, the negative statement with affirmative question tags. You know, I told you before, I said rule number 1, when the statement is in the positive, the question tag will be in the negative form. Now that we have negative statements, the question tags will be in the positive form. So let's have examples of that. Negative statement is the one with the word not. I said a positive statement will not have the word N-O-T, not. But the negative statement will have the word not embedded in it. So let's have these examples. He is not going. He is not going. Don't forget the question tag now will be in the positive. He is not going. Is he? He is not going. Is he? He does not go. Does he? He does not go. Does he? He didn't go. Did he? Don't forget the tenses. Didn't, did. Does not, does. Is not, is. So you mind the tense. Make sure you have the same tenses used, and you have the negative statement now, and the question tag will definitely be in the positive form. Good job, you. Well done. He hasn't gone. He hasn't gone. Has he? He hasn't gone. Has he? Number 5. He won't go. He won't go. What will the question tag be? Will he? He won't go. Will he? Now it's activity time. Did you enjoy the lesson? In today's lesson, we've been able to look at question tags, and we identify basic rules for the use of question tags. If the statement is positive, the question tag will be negative. Number 2, if the statement is negative, the question tag will be what? Positive. Then the tense used for the statement will be the same tense used for the question tag. And then for question tag, you use pronouns. Auntie Fumi is going there. Isn't she? You won't say isn't Auntie Fumi, so you use pronouns. Those are the basic rules. And using the basic rules, now it's activity time. You are to supply the appropriate question tags for these statements. You have just 30 seconds to do that. Your time starts now. Eyes on me. By now, you should have been able to supply 6 question tags. Did you do that? You have enough time to do that. Just write the question tags only. Well done, children. Now let's do the correction. Get your pen and get ready to mark. Wow. You must go home. You must go home. Mustn't you? Mrs. Ismail has traveled, hasn't she? I am not doing my homework now, am I? She didn't buy the bag, did she? The boy will eat the food, won't he? And lastly, Mr. Rufai doesn't live in Agege, does he? Auntie Fumi got 6 out of 6. What about you? You got 6 too. Well done. Oh, 4. Still okay. I celebrate you all with a cheer. Good job, you. Now to your homework. You know Auntie Fumi loves children who do their homework. So please, make sure you do your homework, submit on time, and make sure you indicate your name, your school, your class, and your local government. That is the only way I'll be able to see that you actually do your homework. For your assignment, you are to supply the appropriate question tags. In the next 20 seconds, copy your homework, and I'll come back to sign out. Well done, children. It's been fun learning question tags. And that's it for today. We have come to the end of the English Studies lesson for today. I hope you enjoyed the lesson. Yes. Now we are good at supplying question tags. It's time for me to hand you over to the mathematician, Uncle Agbaje, for the beautifully packaged mathematics lesson. But before I go, I've always told you, I am always proud of you. Good job, you.
Hello, children. You are welcome to this segment of the program, The Classroom in Your Home. It is mathematics time, and today promises to be fun. I am Uncle Agbaje. Today is Monday, and as we do on all Mondays, we begin the lessons with a math-a-thon, which is a 1-minute mental exercise that helps you to practice and hone some of your mathematical skills. We have taught you how to multiply 2-digit numbers by 11. We've also taught you how to multiply all numbers by 5. Just take half of it and add 0. Now let's see how many of these you can do in 1 minute. Begin. Alrighty then, 1 minute is up. How many were you able to do? Well, 59 times 11, 649, 484 here, 957, 693, 440, 429. And there you have multiplication by 5, 430, 420, 240, 360, 300, and 460. Good job you, my friend, as you continue to improve on your mathematical skills. Now, what do we have for today? Today we'll be looking at the units of measuring length, and we've already done a topic on length, and you know, or you're familiar with the measurement of length. But today we are going to go into another aspect of it. Now we move on to today's lesson. What are our learning objectives? By the end of the lesson, you should be able to multiply and divide decimals by powers of 10. You should also be able to state the units of measuring length. Finally, you should be able to make conversions between different units of length. These are the things we should be able to do by the end of this lesson. So without wasting much time, let's get started. Of course, we have introduced length in the previous lessons as the distance between 2 points. And so from one end of the board, for instance, to the other end of the board, how long or how far they have from each other is what we call the distance. But these 2 points could also be the distance from one end of my finger to the other end, or from this point, one side of my finger to the other point, or it could be from your house to my house. Now, length is usually measured in meter or several graduations of the meter, but basically the SI unit of measuring length is the meter. And so that means that if we say that one length is longer than the other, then we are saying it has more meters than the other one. Okay, so there are several graduations of the meter, because it's not the meter that we use all the time. We have some smaller brothers, younger brothers of the meter, and some older brothers of the meter, so to speak. And so what are they? We have the millimeter. You've already come across that before in your work. The millimeter, the centimeter, you've come across that too. Perhaps not the decimeter, but then you have the meter, and then you have what you call the decameter, hectometer, and then you have the kilometer. These are the graduations of the meter. So this is the meter right here. Milli, centi, and deci are smaller graduations. Deca, hecto, and kilo are larger graduations. And there is a song that we used to remind ourselves of all these graduations. The song goes like this: milli, centi, decimeter, deca, hecto, kilometer. Milli, centi, decimeter, deca, hecto, kilometer. Let's take it. Milli, centi, decimeter, deca, hecto, kilometer. Milli, centi, decimeter, deca, hecto, kilometer. You might want to have that song at the back of your mind, because you're going to need it when you start working with conversions. Now, short objects, of course, are measured in millimeters, like the point from one end of your finger to the other side of your finger is a very small distance. So we use millimeters and centimeters to measure things like the length of a leaf, the length of a key, or a paper clip, or a pen, or a carrot, short things like that. We use millimeters and centimeters for that. So if somebody says that, I don't know, somebody says that is 10 millimeters tall, you know that can be possible. Even a dwarf will not be 10 millimeters tall. The millimeters are very small distances. Distances that can be walked or run are measured in meters. That's why you have things like the 100-meter race for the Olympics, 800 meters race, 200 meters race. Distances that you can walk maybe from your parlor, your living room to the kitchen, and longer distances are measured in kilometers. Farther distances that is going to be difficult for you to walk. So one town to another town, perhaps when you taking a cruise in your parents' car, you would have seen a signboard like this that gives the number of kilometers till the next town or the next city. So from Lagos to Abuja, these are far distances. Those are measured in kilometers. It's not possible for one person to be kilometers tall. No, people are measured in meters because that's short distance. Okay, so now let's look at the relationship between all the units of measuring the length. Remember the song? Milli, centi, decimeter, deca, hecto, kilometer. So when you want to know the units of measuring length, just write milli, centi, decimeter, deca, hecto, kilometer. And observe that between each graduation, there is a 10. And that means that 10 millimeter is 1 centimeter. 10 centimeter is 1 decimeter. 10 decimeter is 1 meter. I know some of you check the back of your notebooks for this, but you don't need to. Just write the song. Milli, centi, decimeter, deca, hecto, kilometer. Then put in between 10, 10, 10, 10, 10, 10. In between each. And that's what we're going to be using to find how many of one makes the other. For instance, if you want to go from millimeter to meter, then you have 10, 10, 10. That is 10 times 10 times 10. And that is 1,000, 1 with 3 zeros. So that means that between millimeter and meter, you have 1,000. So 1,000 millimeter actually is 1 meter. Again, if you want to go from meter to hectometer, between meter and hectometer, there are 2 tens. That is 1 and 2 zeros. That means 100 meter makes 1 hectometer. And it's easy to say like that. All right. So let's see how we can now use this in practice. This question says, change 4 kilometers to meters. And I've brought the table here, although I know that you know the song now, so you just write it down and put 10, 10 in between. Now, this question says that we should change 4 kilometers to meters. So what you should observe is that we are going from kilometers to meters. So now you come to your table, which you must have written at the side, kilometer back to meter. Now, between kilometer and meter, how many tens do we have? 1, 2, 3. And so that means we are multiplying by 1,000. 1 and 3 zeros. So if you're going from kilometer to meter, between kilometer and meter, you have 1, 2, 3 tens. So that means your 4 kilometers, you have to multiply it by 1 and 3 zeros, because 10 times 10 times 10 is 1,000. But rather than multiply, just count how many tens you have. 1, 2, 3, and put 3 zeros there. So 4 kilometers to meters is 4 kilometers times 1,000, and that will be 4,000 meters. But note this, we're going from kilometer to meter and we're going up, so you have to keep that 1,000 up there. We're going up, keep it up. What are you keeping up? You count the number of zeros, that's 3 zeros, and you have 1,000. So 4 times 1,000 gives you 4,000, and that means that 4 kilometers is the same as 4,000 meters. Let's check out another example. This example says, change 3.5 meters to millimeters. Okay, so we have meter here because we're going from meters to millimeters. So we have meter here and we have millimeter right up there. And that means that we're going to be multiplying by 1, 2, 3. That's 1,000 again. So we're multiplying our 3.5 meters by 1,000. So 3.5 meters times 1,000. But how do you do this? 3.5 times 1,000? Well, that's where we need to work with multiplying decimal numbers by powers of 10. So if you have 3.5 like this, and you want to multiply by 1,000, all you have to do is 1,000 has 3 zeros, so you're moving to the right when you're multiplying. So you go 1, 2, and then 3. So your decimal point is no longer here. It has ended here. And these 2 blank spaces, now you have to fill them with zeros. So in our final answer, we get 3500 with a decimal point at the end, which we may not need to put. And what we have just done is that we have increased, we have scaled up 3.5 by 1,000, which means that we have moved the decimal places to the left. Okay, so 3 units will now be 3,000 rather, because we have multiplied 3 by 1,000, 3,000. 5 tenths will also move 3 places, it will now be in the 100 place. Then we fill the remaining with 0, so we have 3,500. And so our final answer is 3.5 meters will be 3,500 millimeters. Again, observe that we are multiplying meters by 1,000 because we are going to millimeters. 1, 2, 3. So that's as easy as that. Let's check out a final example of this type. This says, change 430 meters to kilometers. Meters to kilometers. That means we're going from meter to kilometer. Now we're coming down. But how many steps? 1, 2, 3. So we are multiplying by 1,000 below the line. So let's see that in action. That will be 430 meters will now be 430 times 1 all over 1,000. We have to keep that 1,000 below the line because we are coming from meter to kilometer, we're coming down. And now let's see. We can easily eliminate 1 0 here, 1 0 there. And we're going to be left with 43 times 1 is 43, and we'll bring down 100 below. But how do we resolve this 43 over 100? Well, it's also very easy. It's also very easy. Now, we will write this as 43 hundredth anyway. Using our table of place value unit, then we have tenth, and then we have hundredth. So 43 hundredth means that we have to write our 43 somewhere here, starting from the 100. 3, 4. And so if we have 4 and 3, 3 under hundredth, 4 under tenth, then we are left with decimal point and 0 units. And so our final answer will be 0.43. But another way to look at this is to say, this is 43 and we are dividing by 100. If we are multiplying, we are going to move the decimal point to the front. But if we are dividing, we'll be moving it because the decimal point is right here for 43 as a whole number. So we'll move it backwards 2 times because there are 2 zeros. 1, 2. So decimal point is now here. Again, when we were multiplying, we'll move the decimal point forward. But now that we are dividing, we do the exact opposite. And that means we bring it backwards. And the decimal point is now here. And we use a 0 to just make the whole thing tidy because we don't want to start a number with a decimal point. Whichever one you do, my friend, is fine. Whether you say 43 hundredths, write your place value unit, tenth, 100, and put 43 there. And then you remember that there will be a decimal point here and you tidy up everything with 0. The most important thing is that you get the same answer. So 43 over 100 is 0.43. And so our final answer is 0.43 kilometers. Now I'm sure that you're ready for some of your own. Remember, determine where you're coming from and where you're going to. If you're going up, you multiply, keep the number on top. If you're coming down, you multiply, but keep the number below the line. That is 1 over the number. So here are some for you to do. You are to change 12.4 meters to centimeters. You also to change 525 meters to kilometers. I've kept the table of graduations here for you. You have 1 minute 30 seconds. Begin. Alrighty then, I believe that you are done. Let's just review it together. I'm sure you found it very easy. The first one, change 12.4 meters to centimeters. And so if we're going from meter to centimeter, we're keeping it up. But what are we multiplying by? We're simply multiplying by 100. So let's go. That's 12.4 meters, and that's 12.4 times 100 in centimeters. And then we move the decimal places to the right. And so let's just do that here. 12.4 multiplied by 100, we have 2 zeros. 1, 2. Decimal point is now here, and we fill this empty gap with 0. And so that means we have 1, 2, 4, 0. Point whatever it is that comes after, which is 0, but we don't normally write the decimal point at the end of the number because there is no fractional part. Okay, so that's our final answer. I believe that you got that right. 1,240 centimeter. Let's check the next one. This one says change 525 meters to kilometers. So we are going from meter to kilometer. That means we're coming down. But there are 3 tenths there, and so that means that we're multiplying by 1,000. 1 and 3 zeros. So keeping that 1,000 below the line, that's 1 over 1,000. Now, multiplying this, we get 525 over 1,000. Now, using the method of the place value, we can have unit, tenth, hundredth, thousandth. Okay, now we'll fix 525 thousandth. We just fix 525 there. 5, 2, 5. And now we can put decimal point there and put a 0 here to tidy up everything. And that means that our final answer is 0.525. Or you could say 525, decimal point will be here, then move it back 3 times. 1, 2, 3, because there are 3 zeros. So the decimal point is now here. And then put a 0 to tidy up everything. Whichever one you do, you will still get 0.525 as your final answer. Okay. So our answer is 0.525 kilometers. I'm sure that you got that right, but if you did not, you know that I will not leave you out of the loop. I will always give you assignment to practice and practice and practice. And that assignment is coming up right about now. You are to do this. Change 6.25 kilometers to meters. Change 123 centimeters to meters. Change 62 centimeters to millimeters. And remember that table. You don't need that book, that's your notebook that you want to go and check from. Just sing that song along. Millicenti, decimeter, deca, hecto, kilometer, and remember to put a 10 in between each of these graduations. That's been it for the mathematics section for today. I believe that you have learned something new. I will now hand you over to Uncle Popo for the general studies lesson. Till I come your way in the next lesson, remain wonderful mathematicians. Bye bye now.
Hello pupils, you are welcome to General Studies class. I am Uncle Popo. Uncle Popo is here.
I am also here.
Good. We are here together.
100% attention.
Excellent. 100% attention is what I want you to give me in today's lesson as usual. Our subject for today is basic science and technology. In our last lesson, we discussed water projects, and there we talked about definition of water, benefits of water projects, and we also talked about dangers associated with the water projects. Today, we want to look at another very simple topic. Don't forget, in our last lesson, we talked about something very important that all living things cannot do without. And we talked about water. Today, we still want to talk about another thing that no living thing can do without it. And that's what? Who can guess? Well, we've treated water. We can't treat water again. So we want to look at another one. Wow, some have really said it. We want to discuss air. Say that. Air. So what are the learning objectives for today? By the end of the lesson, you should be able to define air, state the properties of air, and mention the uses of air pressure. When talking about air, we are very familiar with it. Now, let me just test you and see if you really understand what I'm talking about. Now, stretch your hand out, blow it. Let's do it. Do your own. Good. And at times when you feel it, some take fan and blow themselves. We are still talking about air. We are very familiar with it. So what is air? Air is the mixture of gases that makes up the Earth's atmosphere. The mixture of gases that make up the Earth's atmosphere. What are the gases we are talking about when we say air is the mixture of gases? Now, talking about the gases, we are talking about nitrogen, oxygen, water vapor, argon, carbon dioxide. These are the gases we are talking about. Looking at these gases, nitrogen takes 78%, while oxygen is 21%, while others take the remaining percent. That shows that nitrogen, oxygen take higher rate when talking about the gases that air is made up of. Now let's look at the properties of air. Now, properties of air. Number one is air takes up space. Say that. Air takes up space. What do we mean? Let's look at these pictures we have here. Look at the two pictures. We want to prove that air takes up space. This is a balloon here, and before the balloon was blown, you can see that it's not as big or heavy like this, but immediately the little guy air blows the air into it, it becomes bigger. And it's just to tell you that air takes up space because air has taken the space inside the balloon to make it bigger. In one word, one of the properties of air is air takes up space. Moving on to the next property. Air is made of gases. When you say air is made of gases, what are the gases? I've talked about it. Nitrogen, oxygen, water vapor, and other minerals. These substances are what give air mass. So air is made of gases, nitrogen, oxygen, water vapor, and other materials. So that's another property of air. Next one is air exerts pressure. Say that. Air exerts pressure. Just like the motor vehicle, the tire of the vehicle, maybe the tire of your daddy's car or any vehicle around you. I believe you have seen vulcanizer trying to inflate a tire before. So the pressure from the machine of that vulcanizer will make the tire to be inflated. I know some of you have seen it before. So that is to tell you that air exerts pressure. That's another property. The next one is air has weight. Say that. Air has weight. Looking at the picture here, I want you to look at this picture. You can see here, this is a blown balloon and this is another blown balloon. Looking at it on the scale, you can see they are of the same page and of the same level because they are inflated the same way. But looking at the second one here, this one is not inflated. This is a flat balloon. This is a filled balloon with air. You can see that this draws, the balloon here draws this one down and this goes up. This is to tell you that this has weight. Why or how? Because it has been inflated, it has been filled with air. That is to tell you that air has weight. Air does what? Air has weight. Next one is air can be compressed. Say that. That's another property. Air can be compressed. This is, I believe some of us have seen some of the spray perfume or the insecticide whereby you spray most times. So we have certain air that have been compressed in those cans. So air can be compressed. That's another property. Air is affected by temperature. That's another property. Just take for instance, if we are two inside this room, you can compare the temperature that we will have when comparing with, let's say, 10 people. You can see that we will start feeling hot, we will start feeling, the temperature will be summer because of the multitude of people comparing to when we have two of us in the same room. Now when we are 10, know the temperature. That is to tell you that air is affected by temperature. It depends. At times when it is sunny, the air, you see that it blows hot. But when it is raining, you see that the breeze, the air will be somehow cold. So air is affected by temperature. Now, having looked at the properties of air, air has weight, air is affected by temperature, and the air exerts pressure. So all this we have discussed in properties of air. Now, let's look at uses of air pressure. Uses of air pressure. 1, inflating tires. That's one of the uses of air pressure. We use air pressure to inflate tires. You know, I told you about that when I was discussing the properties of air. So the air pressure we use in inflating tires, that's one of the uses. Next one is playing musical wind instruments. That's one of the uses of air pressure. We use it in playing musical wind instruments. What are the wind instruments? You have your saxophone. Tell me one. Good. Trumpet, decoder. Excellent. So you have the idea of what we are talking about when we say wind instrument. So we use air pressure. You know, when you want to blow it, you have to exert your air pressure into it before you can blow those wind instruments. Next one is drinking through straw. I know some of you have been doing that. Some still, you did that yesterday. And while drinking through straw, you are exerting air pressure because it takes that air before the water or the drink or the liquid you want to draw will come, because you need to exert air into it. So that's another uses of air pressure. Drinking through straw. That's one of the uses of air pressure. Next one is flushing toilet. Flushing toilet, that your toilet, you need to exert air pressure before the water will draw to flush the waste inside that your toilet. So here, what I'm talking about is air pressure is exerted before your toilet could be flushed. So that's one of the uses too. Moving on to the next one is drawing water from well. That's one of the uses of air pressure. Again, operating a barometer, pressing this, it takes the air into it before this barometer could be operated. So operating a barometer, that's another use of air pressure. Blowing up balloon. So to blow up balloon, you are exerting air pressure into it. That's one of the uses too. And lastly, breathing. Before you could breathe in or you breathe out, what kind of gas do we breathe in? Good, I have brilliant pupils here. You breathe in oxygen and you breathe out carbon dioxide. While plants breathe in carbon dioxide and breathe out oxygen. Do you understand? So breathing, that's another use of air pressure for breathing. In today's lesson, we have talked about the following. When we started, we defined what air is. You were told that air is a mixture of gases that make up the Earth's surface. And we talked about the gases there. We talked about nitrogen, oxygen, water vapor, and other materials. We also discussed properties of air. You were told that air exerts pressure, air has weight, air can be compressed, air is affected by temperature. Likewise, common uses of air pressure in daily life, and inflating tires, playing musical wind instruments, drinking through straw, flushing toilets, drawing water from well, operating barometer, blowing up balloon, and breathing. All these we discussed in today's lesson. Now it's time to test and see if truly you have given me your 100% attention in today's lesson. I have few questions. Question number 1. What is air? Question number 2. State 2 properties of air. Question number 3. List 3 common uses of air. You have 50 seconds to attempt this. Your time starts now. Eyes on me. Uncle Popo is here. I believe you are still there. So when you are still there, let's mark together. What is air? Air is the mixture of gases that make up the Earth's atmosphere. Is that what you wrote? Brilliant one. Now, 2 properties of air. Air exerts pressure, air has weight, air can be compressed, air is affected by temperature. We have many of these properties that we discussed today. Any of the 2, you are very correct. List 3 common uses of air. Inflating tires, playing musical wind instruments, drinking through straw, flushing toilets, breathing, and any of the uses that we discussed in today's lesson, you are still very much correct. You got 3/3 or 2/3, you are my best friend. You deserve to be given a chair. We have come to the end of today's lesson. Until next time, next lesson, Uncle Popo says, keep on studying. Bye.
Dear pupils, we have come to the end of another exciting episode on the Classroom in Your Home.
We hope that you have enjoyed yourself and that you have learned a lot of new things today. Now, we want you to take time out to practice using the online assessment that we have put in place for you. The link for today's online assessment is bit.ly/Lasubeb lesson 85. The link again is bit.ly/Lasubeb lesson 85. Don't forget that this is our own way of knowing how well you're performing in order to help you to improve on your performance.
Taking the online assessment or test is based on if you have access to either your daddy's, your mommy's, your uncle's, or your auntie's Android or smartphones. But if not, there's no problem. Just send your comments, your questions, and your assignment to 081 50 86 5663. Please, it is SMS and WhatsApp messages only. Do not call that line. And when you are sending your assignment, make sure you indicate your name,
Your school,
Your class,
and your local government education authority. That is the only way we'll be able to identify you and appraise you accordingly.
wow, wonderful experience we had in today's lesson. All these lessons are on Lasubeb YouTube channel for you to watch over and over again. Subscribe to Lagos YouTube channel to get notification when new videos are uploaded. The Classroom in Your Home could be watched live on Facebook through the page showing on the screen.
Till our next lesson, when we shall meet again for another beautifully packaged edition, make sure you do your homework.
Wash your hands regularly.
study hard, and
Stay safe. Lasubeb, leave no child behind.